Binary search may seem complicated and convoluted to understand, but fear not. In this video, we will break down binary search and show you how powerful it can be. As a bonus, we will code a binary search function in Python in this new modern theme that VS Code released. So, here is binary search made simple. So if I asked you to find an element in a list without using a built-in function, what would you do? Probably go through the whole list and check each element to see if it matches the value. But you can get 2 times that efficiency by using binary search. This is why many programming languages have a built-in search function that optimizes this method. It's just the faster way. So now let's take a look at this list. A, B, C, D, E, F, G. All of these are strings, and their values in the list. We have to find the letter E. So first, we're going to split the list in half. And then we're going to check, is E on the left side or the right side? It doesn't matter what side it's on, but for our purpose, it's on the right side. So then we're going to check. We're going to split it again, and then we're going to check, is it on the left side or the right side? So now E is on the left side. So we keep doing this recursively until we split between 2 letters, and one of the sides is the value we need, or the middle is the letter we need. Because for a list that has an odd number of values, your middle is going to be an element in the list. So you're going to need to take that into account. Alright, that's literally all there is to it. It's a very simple concept, and we're just going to code it up. So let's get to it. Okay, so let's start off with defining our function. I'm going to call it search. And then we need our value that we're searching for, and the data set, which is the list. So the first thing we have to do is find the middle. And again, this is an index. So we're going to say it is rounding the length of the data divided by 2. So we're taking the data, we're cutting it in half and just finding that index. And then comes our base case. If the data submiddle is equal to our value, so we're checking if it's an odd-numbered list, it could be possible, then we just return the middle. Since we need our index, we got it. And the data submiddle is what it's a middle and then the value is the value, so yeah, whatever. Okay, and if that's not the case, then we gotta keep going. So let's set up left, and that's going to be an empty list, and we're going to add on to it. And for that, we're going to need index, which is IDX, and we're going to set that to 0. Now we're going to use a while loop. So while not data sub index is equal to data sub middle. So this is basically checking like we're going in a straight line. So we're checking each and every letter to see if it matches our middle without the middle. So when we finish with the left, it's not going to include the middle in case it's a letter. So while non-data IDX is whatever, left, so we have to do left.append data sub index. So and this data IDX is updating because we are adding to it. We're adding 1 every time. Alright, now we have our left. Now we still need our right side. So we're going to say right is equal to data sub colon. This, we add this colon part, that's because it doesn't tamper with the data list. If we remove it, then the data list would get messed up and things would happen that we don't want to happen. So this ensures that data stays the same and everything goes smoothly. And since we don't want the right side of the list to be equal to the whole list, that would be weird, we need to remove the left side. So for I in range, length of left, our list, we're going to remove from right, left sub I. And there you go. So we got our left and our right. Now all there's left to do is check. So if value in left, this is a quick function to check, then we can return search value left, because that is now the new list that we have to split. Else if value in right, we have to return the same thing, just the right list. So, whoops, right, okay. And there you go. Except there's something missing. We don't have the middle. So if the middle could be nothing, or it could be a letter. Remember that. So we have to add middle to this value in case it got left out. That's key. All right. That's literally the whole function right there. 19 lines of code. Not bad. So now let's actually get this function tested. So we have our value D, and I'm going to have the data equal to the list A through G. Alright, that took a little longer than I expected it to take, but that's okay. And now we can just print out our search, value, and data. There you go. Now let's run this function. And there you go, you get 3. Now let's check if that's correct. A, so we start at 0, 0, 1, 2, 3. That is correct. Now we can put in something like F. Let's give that a test. 5. So we know D is 3, 4, 5. That is a working binary search function. And again, this is very simple code, but the key idea is to understand the idea of binary search. That is why we do this. It really helps. And that's binary search. So we hope you enjoyed the video and learned something new. If you like what you saw, make sure you give this video a thumbs up and subscribe for more awesome programming content. If you think it's awesome. If you think it sucks, that's okay too. Now go forth and search like a pro, because that's what I taught you to do. Thanks for watching, and we'll catch you in the next video.